There will be two separate videos on how to create this X table, one of which uses sheet metal techniques. The completed model here has sheet metal features, and the other method will use surface modeling. And both methods lead to pretty much the same result, and both are relatively simple to produce. If we do take a quick look at the geometry, this is a solid model and probably looks like it was created using solid modeling techniques, cuts and extrusions. And this is possible. You can do it that way, but it's actually quite difficult. I didn't actually bother going into the process of creating this, as there's quite a few sketches that you have to create all the cuts that you need to produce this using just the solid modeling features. This video will cover the surfacing method, and so I have the X-table surfacing open. And to save a little bit of time, I've already created 4 planar surfaces, and these will be used for the outside of the X-table. If I take a quick look at a sketch, it's simply a trapezoid, and it's spaced off from the side by 0.65 inches, which is going to be the radius of that outside bend. So I'll go ahead and hide away the planes as we no longer need them. And the first thing we want to do is create our fillets. And these we're going to create using boundary surfaces. And so the first thing we'll do is create 3D sketches for each of these fillets. So I'll go ahead and add 2 splines to these corners. And I want these to be curvature continuous to the ends. But first I'm going to go ahead and select the spline and this outside edge, make it tangent, and do the same on the other side. And then I'm going to add a curvature continuous relationship to that. The reason I added this first is that if you add the curvature continuous relation beforehand, which is selecting the spline and control selecting the edge and the face, it actually puts this spline in the wrong direction. So in this case we wanted to put the tangent relationship in first. And we'll add this relation to all 4 of these corners. And you notice it doesn't matter if I select out this edge or this as the edge. So I'll just go ahead and go around and create 4 of these sketches. All with the same relationships. And I'll go ahead and do the same for the other 2. And I'm going to go ahead and edit forward in this video, so we'll go ahead and skip having to see me add in these extra sketches, but I'll go ahead and just add those in right now, and then we'll move on to the next step. Okay, so now we've skipped ahead and we have all of the sketches that are necessary. And we're going to go ahead and just select the boundary surface. And then we're going to be using the selection manager as we have multiple contours in each sketch. And for our direction 1, we can choose those 2 splines. We can also choose in the direction to these edges if we wanted. But looking closer at the curvature combs, you can see that the curvature is continuous at each of these sections, so there isn't really much of a necessity to grab those other 2 edges. And we'll go ahead and just do that for the other 3 sections. And sometimes these will cross, so you'll just have to reselect out the edges, and they should line up fine. So next we can create a knit surface out of this, but first it looks like I have 1 spline that's actually incorrect here. So I'm going to go ahead and repair that before moving on. And I'll get an error with the boundary surface as now it's missing that loop. And now that looks to be the correct surface. So I'll go ahead and just choose out all of these surfaces and knit them together. I'm also going to go ahead and just drop in appearance, as I really didn't like the dull gray that was in there before. So next we want to create the cutouts in the side. So I'll first start a sketch on this face. And I'm just going to choose the offset entities, reverse the direction, and choose 1 inch. And I don't need the top or bottom edges, so I'll take those out. Then I want to go ahead and add an edge to the bottom. Make sure the converted edge is free floating on both sides. And then merge the top. And the reason I drag this in advance is that once I drag it, it goes from fully defined to underdefined. Otherwise, we wouldn't be able to use the merged condition. Then I'm going to go ahead and create a fillet at all 3 corners of 1/2 inch. And now I want to add this same sketch to these 2 faces. And for that, I'm going to create a derived sketch. So first we'll click on the sketch 6 and then control click this face and go to insert and choose derived sketch. And that'll keep all the geometry, but we'll need to reposition this. So I'm going to go ahead and go into the Sketch Tools and go to Modify, and I want to flip this horizontally, and I can do that just by hovering over this dot and right-clicking. Then I want to go ahead and make these two collinear. And you'll notice the only entity, or I can't use any sketch entities. The only item I can use here is the Smart Dimension. So I'll dimension this off from the side by 1 inch. And then we'll go ahead and do this one more time on the other side with a derived sketch. Once again, use that modify command with the right click to flip this. And we'll make these two collinear. And then just give this a dimension. Now just to remove these out, we're going to use the trim surface with the remove selections. And just do this 3 times. And I'll go ahead and choose to thicken the surface. We'll go ahead and put the material on the inside. And there we have the completed X table. So you can see this is fairly simple if you know the tools that you need to use within surfacing. And this would save you quite a bit of time over trying to do this with a solid modeling approach.